Cool. Okay, welcome to recording 3. This is week 5 in the C++, and we're just talking about loops and the different types of iteration that we have available to us in C++. So here's kind of a top-down look at the different loops that we have available. So we have the for loop, which goes a specific number of times. We have the range-based for loop, which is a one iteration for each element of in a range or a collection. So that was introduced in C++11. It's actually very helpful. So we'll talk about that in a little bit. And then we have the while loop, which will iterate while a condition remains true. And then we have the do while loop, which will iterate no matter what once, and then while a condition remains true. Awesome. Okay, so let's talk about those in the order that I just talked about them there. So we'll get into a little bit more detail. So the for loop syntax kind of looks like this. So you have the initialization, the condition, and then the increment that you want to do. So you can include one statement underneath, or you can do curly braces and have multiple statements in it. And here's a little bit more of a detailed look at what that might look like. So we use our C++ list initialization. We do int I 1, I while I is less than or equal to 5 plus I or I plus plus, okay? You can do either or, it's the same thing here, it doesn't matter. And then what we're doing here is we're C out the number I. So this should start 1, 2, 3, 4, 5 and print that out to the console. All right, and then this next one here, int I equals 1, you can use the old syntax if you do like it, but keep in mind I is only visible in the loop. Okay, so I'm going to be using the C list initialization like this from C++11. You can use this if you're more comfortable with that, but just keep in mind I is only visible in the loop. So if you try to set I later down to 100 and see how we're not in curly braces here, there's going to be an error. Okay. Cool. So here is an example with an array. We have an array of ints called scores, and we've put 3 elements in it, 100, 90, and 87. So we're doing int I 0. So for int I 0, so we're initializing it to 0. And then we're saying while I is less than 3, okay, plus plus I. So iterate I by 1. So that's shorthand for I equals I plus 1. Now, you can do this 2 ways, okay? You can do I less than the size of the array, or I less than the size of the array minus I less than or equal to the size of the array minus 1. So here's the 2 examples here. It's really up to you, but try to keep consistent what you do throughout your programming career. So in example 1 here, okay, this is example 1. We have the greater than symbol, and then 1, 2, 3. I'm just going to do little dots because I can't draw everything. But keep in mind, that's the greater than symbol that we're using. Now your second option, so that's option 1. Oops, your second option is option 2. Option 2 is this one here, okay? Now it's a little bit messy. Whoops. Now option 2 is you use the greater than or equal to symbol instead of just the the less than or equal to symbol instead of just the less than symbol. But then instead of comparing 1, 2, 3, like the actual elements in the array and writing 3 here, you do the size of the array, 1, 2, 3, minus 1. So you do a 2 instead of a 3, okay? They're the same thing. It just really depends what you like. Sometimes people can get confused, and this 2 here, they'll just still write 3, but then they're saying less than or equal to 3, which would be 0, 1, 2, 3, which would actually be 4 elements, and you'd get an error because you'd be out of bounds of the array. So just whatever you are comfortable with and whatever makes sense to you, the C out in both of these examples would be the same thing. Just keep in mind while you're iterating through an array that you're using the correct size of the array. All right, now you can also do the comma operator. Now tell me, have you guys done this before in the chat? So I know whether or not to just briefly touch on this or describe it a little bit in more detail. But you can have a for loop with multiple initializations and iterations in it. So here we have 2 variables that are being declared. One is going to be I at 1, and one is going to be, after the comma, j initialized to 5. Okay, and then while I is less than or equal to 5, okay, so it's 1, 2, 3, 4, 5. we are going to do an increment of I and an increment of j. So we're going to do I plus plus and plus plus j, or plus plus I plus plus j, and we're going to see out I times the value of j is, and then we're going to actually do the mathematical operation I times j, and you're going to get an output that looks like this. 1 times 5 equals 5, 2 times 6 equals 12, 3 times 7 equals 21, and so on. All right, does that make sense? So you have two variables and you're iterating through both of them, and they're going to both be in the for loop, and we can use them as we go up. One was just defined at 1, and one was defined at 5. So this is going to be 5 to 9. This one's going to be 1 to 5. Pretty clear? Cool. Some other details with the for loop, it's pretty clear and concise, but because all the expressions are optional, it's possible to have no initialization, no test, and no increment. So this is technically a correct definition of a for loop with 2 semicolons in it. There's no initialization, no test, and no increment. And then you can just have a cout of an endless loop here, and it will just keep on looping and looping and looping because there's no variable to say I hit my number and I'm going to exit the loop. So it is possible to have an endless loop. Obviously, we don't want to have an endless loop for memory reasons. So just keep that in mind. Cool. So I'm going to show you guys an example, not in the if-else nests main CPP, but in the week 5 loop CPP. I'll set that to my active project, and then I will do come up here and uncomment some stuff here. So I've included vector and I've included IO manip, and this is something that we use for formatting later on, and you'll see that. I'm using the namespace standard, and then we're just going to do some simple for loops here at the beginning, okay? So the first for loop here, I've declared I've initialized the variable I and j after the comma, all in the very first section of my for loop, okay? Then I'm going to do the loop as long as the value of I is less than or equal to 5. Then each loop iteration, I will plus plus or iterate my I and my j counter. Then I will, for each loop iteration, see how I've tabbed in here, print out the value of I, print out the value of j, and equal it to I plus j. So we should expect to see 1 plus 5 equals 6. 2 plus 7 equals 9, etc. Okay? So let's just hope that works here. Okay, main.cpp. And run it. There we go. And as we can see, we've got 1 plus 5 equals 6, 2 plus 6 equals 8. Sorry, I said 2 plus 7. 2 plus 6 equals 8. And it's going to iterate by 1 each time. This is the value of I, 1, 2, 3, 4, 5. This is the value of j, 5, 6, 7, 8, 9. And then we're just adding the actual two values, so this should be mathematically correct. Okay, cool. So that's that simple for loop. Okay. Okay, so this example here, we are declaring another for loop with the value of I set to 1. While I is less than 100, we're going to iterate I. And then for each value or each iteration of the loop, we're going to print out the value of I here. So we should see 1 to 100. Then we have an if statement, okay? So if I is divisible by 10, okay, then we're going to print out an end line. Else, we're going to print out a space, okay? And at the very end of the loop here, we're going to see out I, sorry, we're going to see out I, oh, sorry, that is just the ternary operator, so I will just comment that out for now. That's the same thing, this if-else statement put into one line with the ternary operator, so I'll cover that in a second. So we have an if-else, we're checking if it's divisible by 10, then we enter a new line. So as we can see here, I've got the numbers 1 to 100 printed out, but every 10 numbers, okay, a new line has been printed. So we see out end line. And then at the end of 10, we went to a new line and we did 11 to 20, 21 to 30, and so on. Okay, now if I comment this out, and then I uncomment out my ternary operator or my conditional operator, It's the exact same thing. I'm going to see out. Okay, I can comment this one out too. Um, I can see out the letter I, which is what I'm doing here on line 16. But then I'm also going to check if it's divisible by 10. If that's true, print a new line. If it's false, print a space, okay? And it should be the exact same output. I did Control F5 to run and build the program, and there is our output. This is the exact same thing, okay? So that's that ternary operator. Awesome. Okay. All right, so I want you guys to open up CodeLight and really quick in-class lab for you guys. I want you guys to write code that uses a for loop to calculate the sum of the odd integers from 1 to 15 inclusive, okay? The final result should be stored in an integer variable named sum. You can name it whatever you want, but how would we do this program? I'll leave this up on the screen. Open up CodeLight. I'll just open my CodeLight on another screen here, and I want you guys to discuss or figure out or try to code, and then maybe share your screen once you have it, um, how we would accomplish this task. What do you guys think? So just like we just checked if something's divisible by 10, we can check if something's divisible by 2, which would give us evens or odds. And we want our for loop to be from 1 to 15 inclusive and only print out the sum of odd integers. So we would want to add all of the odd values. How would we do that? I'll bring my CodeLight down here. I'll just start working away, but I want you guys to help me out here. What would we do? Just like here, we did a loop to 100. We can do a loop to 15, right? So we want to be from 1 to 15 inclusive. Now, how do we get odd numbers only? In the loop from 1 to 15, okay, so we have an if statement, whoops, in the loop. Remember, our tabs are very important. If, okay, and Raden is saying, if it's divisible by 2, sorry, it does not equal 0. Yep, you're right. If it's divisible by 2, it does not equal 0. All right, then what? We want, okay, so we need a variable called sum. So I'll just declare a variable called sum here and initialize it to nothing. And you're saying you want to do sum plus equals I. Okay. And then we want to print out at the end of it, see out sum, something like that. We'll make this 0. I've got an error in here somewhere. Oh, okay. 64. Is that correct? We got 64. Um, let's see. All the odd numbers from 15. So we do 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15. 64. Very nice. Simon Radhan, very good. Okay, cool, guys. Thanks. So that is how we would do it. Nice. Okay, cool. All right, another example of a for loop using a vector here, okay? So I just want to comment out these lines. So we've got a vector of ints called nums, and I've put in the values 10, 20, 30, 40, 50 in here, okay? And basically, we're going to get an error here if I don't put unsigned I of 0, okay? So like this, I did int I1. Same thing, I'm doing int I0, but I'm going to get an error because we're comparing basically an unsigned int to an int. So if I just did int I0 here, and I tried to run this, we should get a warning or an error basically saying, okay, so it's just a warning, basically saying you're comparing an integer expression of different signedness. Signedness. Int is being compared to unsigned. So what that means, long unsigned is being compared to signed int. Basically, signed means it can be positive or negative. Unsigned means it can only be positive. Now, we're comparing I to be less than nums.size, which is the size of this array, which is 0, 1, 2, 3, 4, right? Or 5, I guess. And it starts at 0. So it's 5, right? That's the size. Now, the size of a vector can never be negative. So we're basically, it's saying you're comparing um, this int I, which can be negative, right? Because it's a signed int, which means it can be either negative or positive. So I could do minus minus to it, to something that can never be negative. So it's saying we want warning, we want to use unsigned here because basically now this can never be negative, and if I try to do plus plus or minus minus to it, it won't work. So now I'm comparing it to nums.size, which will be 5. As long as it's less than that, it'll print out nums I. Now I'm using the array syntax here. Now, that won't give me bounds checking, but if I do the dot at I, then that would give me bounds checking. It'll still work. I can do Control F5 and run this, and we should be able to see 10, 20, 30, 40, 50 printed out there from the array. And there's a new line at the end of each one. Cool. All right, I'll comment that out. Now we're going to move on to the next section here, which is the range-based for loop. And this is an awesome addition introduced in modern C++, C++11, which is basically saying for var type, var name in the sequence that it is. So it'll basically iterate once for every element that is in an array or in a vector. So if there's 5 elements in that vector, it'll automatically go one time for every element in that vector. So this is how you declare it. You have an array here, and then you say int score in scores. So there's a very similar method. I don't know which one it is in Java, but it's like for each, I think. For each, I believe this is the same thing as a for each loop in Java. And if it's not Java, then it's either C# or something like that. But a range-based for loop is basically saying for each score in the scores array, then it will loop through and print 190 and 97. And then we don't have to say while I is less than 3, while I is less than array.size, whatever. You can even let it assume the type of element in the array or in the list that you're comparing it to by using the auto keyword here. So for auto score, and it's going to come up here to the array of scores and see that it's an array of ints. And it's going to automatically assume for each int that there is in the arrays, and it's going to count it 1, 2, 3. So it's going to loop through it 3 times and then see out the score and end line 190, 97, and that's what it does. Another example of how it works, so if we have a vector of doubles, and there's temperatures in it, okay? And we have 1, 2, 3, 4 temperatures in it, okay? And then we have these 2 variables, average temp and running sum for auto. So we're gonna just let it assume that it's of type double, right? Because it's a vector of doubles. For auto temp in temps, so for each one of these elements in the temps vector, 1, 2, 3, 4, then we're gonna do the running sum plus equals temp. And then we're going to set the average temp equal to running sum divided by temps.size, which would be that total, so whatever this is, 100 or 240, divided by 4, and you're going to get your average temperature of 77 or something like that, right? You can also use an actual initializer list instead of an array or instead of a vector inside of that. So what you could do is just put the temperatures directly inside of here and say auto temp in, and you can call this anything. You don't have to call it temp. You could call it X, you could call it I, whatever you want. For each element in 1, 2, 3, 4, this a list of 4 items, we're going to make the running sum plus equal to this element value or variable we declared, so temp in this case, and then plus plus size. So the only downside to using an initializer list versus an array is there's no size method. So you have to declare your own variable called size and then iterate it for each loop and then divide it by the size because you won't have access to the arrays or vectors.size method. Okay. Another example of the range-based for loop here, if you wanted to loop through, say, a string, then you can say auto C. So it's just going to go and see that this is a string. So for each string or character in the name Frank, then it will print out the C or the element at that index. So 1, 2, 3, 4, 5 elements. It's going to start at the 0 element or the 0 index and print out FRANK. All right. So let's go to CodeLight and let's take a look at range-based for loops. Okay. So here we have range-based for loops, and I'm creating an array. And I'm just going to let the compiler see that the size is 3 and it's got the values 10, 20, and 30 in it. And I can replace int with the auto keyword here, and it will tell the compiler to figure out the type. So I don't have to say for int score in scores. I can just do auto score in scores. And then I'm going to print out each score and then a new line. Okay, so control F5. And 10, 20, 30, that is exactly what we expect. Cool. And a vector example here. Okay. So same thing, we've got temperatures here. So we've got a couple temperatures in Celsius, and we've got a double called average temp and a double called total temp. So for auto temp in temps, so that's the name of my array, or my vector. I was going to say array list. The name of my vector here. So for each element in my vector, I'm going to add it to my total. So you'll see if I print out my total later, the total will be like 200 or something. And then basically if temps.size is not equal to 0, so we're just checking to make sure that this array is not empty. For some reason, let's say it was empty. Then we will divide it by the average temp. We will set it to be equal to the total divided by the array, the vector.size method. Now, the reason we're checking to make sure it's not 0 is because if it is 0, then we avoid a divide by 0 error here. So we wouldn't do 200 divided by 0 because that would do a runtime error. So we're just checking to make sure it's not equal to 0, setting it to our average temp. Now, this is the first time you've seen me use set precision, which is basically formatting. So we want to set the precision of our double to be 1 decimal place, and you have to include the IO manip or manipulation operator preprocessor directive in order to use the set precision. Okay, so what we're doing is we're setting the precision of this AVG temp double. That's going to be printed out, okay? So let's run this code and you'll see what happens. So we've got the average temperature is 24.8, total is 124. So if you take 124 and divide it by 5, I'm sure you'll get this number 24.8. Now if I didn't include line 51, which was the set precision, then what would happen is this would be 24.854 or something like that, and it would just go to whatever value it goes to automatically. So we're just truncating it or fixing the precision to 1 decimal place. All right. So I'll just comment that out. And one last example with a string before we get into while loops for our range-based for loop. Okay. So we've got 2 strings here. I'm going to comment out this second one, and we're just going to focus on this one here. Line 58. So for auto C, and then I've got a string saying this is a test. So for each element in this string, which is, you know, THIS space IS space A space TEST. If C does not equal a space, then we will print out the value. So as long as it's not a space, we're going to print out the value. If it is a space, then it's just going to skip the code. So we should just get the same sentence with no spaces, right? So we'll run that code and let's look. There it is. There's no spaces in there. So you can do some really cool manipulation to strings with this. You can print out, you know, every You can take out vowels. You can take out or capitalize things after periods automatically. You can uh, really, you can make whatever rules you want. This one, we're using the same sentence. We're using the auto keyword. And if C is equal to a space, then we're going to print out a tab character, the \T. Else, we're just going to print out the C. So then what that will do is it'll transform or convert each of the spaces to tabs. So it should be really far apart. And then I think, is it going to do a new line for each iteration of the loop? Let's run it and let's see. So it does an end line at the end of the loop. So we can see it made each of those spaces a tab, right? You can have fun with that. You can make that really whatever you want. But so that is range-based for loops. Cool. Awesome. Okay, let's talk about while loops now. So while loops basically are they're a perfect example of something we call a pre-test loop. So you test the expression or the condition first before the actual statement gets executed. So the test is done before the loop happens. Sometimes it's possible the loop will never happen if your expression evaluates to false, right? And you can do one statement, or again, you can include curly braces and do multiple statements. So here's an example of a while loop. While I is less than or equal to 5, okay, so we've declared a variable called I up here and initialized it to 1. So while it's less than or equal to 5, print I to the console and then iterate I. If you don't do the plus plus I or I plus plus, then you'll have an infinite loop because it'll always stay 1, right? So we print 1, 2, 3, 4, 5 because it's iterating and then the loop ends. We don't want an infinite loop, so make sure you iterate it. Again, same thing here. We're just checking to see if it's divisible by 2, and while it's less than 10, and we're printing out even numbers between 1 to 10. So we get 2, 4, 6, 8, 10. Another example with an array. So we have an array of scores, and we've got our int of I initialized to 0. While I is less than our size of our array, 3, then we're going to print out the scores at that index and then iterate. So we'll print out each index of the array. Another one for valid input validation. So you want the user to enter a number between certain integers. So enter a number that is less than 100, okay? So we can have our while condition to be checking the number is less than or equal to 100, okay? And then inside of that loop, we can see it says enter an integer less than 100, in number. So it's gonna keep on asking for another number, and it will exit the loop once it's less than 100, and then just say thanks. Now, here we can see these two lines of code, enter an integer less than 100 and in number, are duplicated. Typically, when you see code duplicated in your program, that's a good hint or a good reminder that you can probably make your code more efficient and you can do it a better way. So, for example, a do while loop, we could do the do asking for that number while the number is less than 100, and it would only print out, we'd only have to write the code once. We'll get to that in a little bit. So input validation, we can enter a number between 1 and 5. So this is checking on both ends. It's checking the minimums and the maximums, and we're using our Boolean operator of the OR with the 2 pipes. And we're saying while number is less than or equal to 1, or number is greater than or equal to 5, enter an integer between 1 and 5, and we'll just keep on asking. One last one with a Boolean flag. So another common thing you'll see with while loops is basically you could have a Boolean called is dead or is alive. And while that is true, then the code inside will run. So in this case, we've got a bool called done, and we're saying while not done. So you just put that Boolean exclamation mark expression in front of it. So while not done, then do this code in here. Enter an integer between 1 and 5, take the number and store it in your buffer, and then check if it's between 1 and 5, and then print out of range, try again, else thanks. Now it's very important that you set done equal to true again, or you'll have an infinite loop, okay? If you never set done to true, then this will always be false. Now you also have to remember with Boolean condition loops that you have to initialize them to false or true. If they're not initialized to something, then your loop will error. Let's go to CodeLight and take a couple looks at some while loop examples. So this very first one here, we've got an int called num, and we're asking for a positive integer to start the countdown, okay? Now we store that in the buffer, and then while num is greater than 0, then we print num out to the screen, and then we subtract. So we do minus minus, okay? Then once num is actually equal to 0 or less than 0, this condition will no longer be true because it's not greater than 0. So it'll exit and it will print blast off. Okay, so we'll just do Control F5, build and run, and basically it's going to ask me to enter a number to start the countdown. I can put in 15, and it will count from 15, 14, 13, all the way down to 1, blast off. Okay, and it's just going to keep repeating this loop until that condition is not true. All right. I'll comment that out and we'll do another one for input validation. Okay, so this is another example. We're asking for a number that's less than variable. Now, while that number is greater than or equal to 100, we ask for them to enter that number again and store it in the variable. Once it's actually less than 100, we print out thanks. So this is the same one I showed you guys on the slide. This is what it looks like when it runs. So I could put in 101. It'll keep on running, right? Enter an integer less than 100. If I put in 77, thanks, and it will exit. So that'll literally run forever unless I give it what it wants. Cool, so it's a cool way to input, to validate your input. Now another example here that we talked about was using a bool, and we set it to false. Okay, we set it to false so we can enter the loop the very first time because it's checking while not done, or basically not true. So while this is false, then we're going to ask for an integer between 1 and 5, store it in the variable, and then check our if it's less than or equal to 1, or it's greater than or equal to 5, and then say it's out of range. If it's in between 1 and 5, then we're going to say thanks and then set done to true. If this is not set to true, we'll never exit the loop. So I'll just run this here and you'll get a little example of enter an integer between 1 and 5. Let's enter 0. Out of range, try again. If I enter 6, 7, 8, 9, nothing. If I enter 3, thanks. Cool. And done is equal to true. Awesome. I'll comment that back out, and we'll go back to the PowerPoint to talk about our do-while loops as the last type of loop in C++. So our do-while loops basically are, remember we talked about a pre-test loop, which is while, and then it does the condition. Our do-while loops are an example of a post-test loop. It'll guarantee the loop will execute at least once. So it's going to do the statement and then check while, and then we'll check the expression. Okay, so this is a post-test loop, and if you want your expression to run at least one time, then you use a do-while, okay? That's how you know the difference between when to use a while and a do-while. So here, for input validation, here's a better example of what we could have done in the past or previous example. So notice here, our number is declared outside of the do section. This is because it's referenced in the while section. So this int number here is actually initialized outside of here so that we can reference it later outside of the do brackets or the curly braces. All right. If we don't declare it outside, then we're going to get a compiler error because it's not going to know where or what we're looking for. So we declare a number variable here and initialize it to nothing. And then we say do. So basically this will run once no matter what. Enter an integer between 1 and 5 and then store that number in the buffer. While, and now it checks the condition, while number is less than or equal to 1 or number is greater than or equal to 5, it's going to continue doing this. And then it will say thanks once that condition is actually met. So basically it'll do this once and then check, and then if that still is false, it'll check again, and if it's still false, it'll check again. If it's true, it'll exit and run the code after the loop. Another example of area calculation with to calculate the area of a rectangle or of a square or anything. So you have this char of selection, okay? And what I'm doing here, you don't have to understand all of the code, but basically we're asking for the width and the height separated by a space, and then we store that in variables. We take the area and times width times height, and then we print out the area is, and then we ask the user if they would like to calculate another yes or no, and then store that. And then in the actual condition, then we say if the selection is yes, uppercase y or lowercase y, then we're going to do it again. So it's like, would you like to calculate another? Yes or no, do it again. So it's difficult to know whether or not you want to use a do while or a while loop. But if you know that your loop's going to run once, then a do while loop's the clear choice. So here we know that they want to calculate at least one rectangle. So we're going to do a do while loop and then ask if they want to do another. If not, we just exit the loop. All right, so let's go look at CodeLight and see some examples of do while loops. Okay, so this one is, whoops, do while loops and go. So it's a little bit of code, but we're going to walk through it. So I'm creating this variable called selection, and I'm going to save it in the type char. All right, and we're going to print out this menu. And it looks like a lot of code, but don't worry about it. We're printing out a bunch of different lines that basically say option one, option two, whoops, option three, and then Q for quit. And then it asks the user for their selection, and it saves it in that selection variable. All right, and this is all within the do loop. So it's going to print this menu, and then it's going to print this menu while my condition is not met, or while it is met, right? So while the selection is not equal to Q, uppercase Q, or lowercase q, which is for quit, so as long as they select something other than Q, then we're going to continue to loop everything in the do section or in the braces, okay? So then I have an if statement here, which checks if the selection is equal to 1, you chose 1, and I just print it out. If the selection is equal to 2, you chose 2. And you could put whatever code that's actually in here. Like if it's calculate the area of a circle, you could have that. If it's calculate the area of a square, you could have the code there, right? But I'm just printing out you chose selection 2, you chose selection 3, and then if they select Q, and I just print goodbye, and then we'll actually exit the loop. Otherwise, if there's some other option, if they chose 17, it's just going to say unknown option. So let's run this do while loop. It'll print the menu at least once. I know that I want to print the menu once, so I usually use a do while loop to do that. And if I want to do option one, it's going to say you chose 1 doing this, and then it's going to bring me back to that loop again because I didn't press Q. I can choose 2, I can choose 3. It's going to keep on looping. I can choose 4, and look, it's going to say unknown option, try again. I can choose 255, unknown option, try again. As soon as I enter Q, it's going to say goodbye, and then the program exits and says press any key to continue, and I exit. All right, so that is the do while loop with a little bit of a bigger or more complex example. All right, cool. Now, a couple other things to cover. Continue and break statements. So a break statement, like we talked about with the case statement, is going to just break out of a loop, and the loop will be immediately terminated, and all that control will just basically go to the statement following the loop construct, so whatever line is after the curly braces. A continue basically will just continue through the program. It'll control will go immediately to the beginning of the loop again, so it'll stop there and no further statements in the loop are going to be executed, but it will continue back to the beginning. So if you have a continue statement and you don't want the rest of the loop to run at a certain sequence or something, then you can just go back to the beginning of the loop and it will keep looping. Okay, so that's the continue and the break keywords. So here's some examples of it. If you wanted to break as soon as a value of -99 was met, then that would happen here because it's checking if the value is equal to -99, break. Else if the value is equal to -1, continue, it'll go back up to the beginning and check until it hits a -99 again. If there's not a -1, then it will just see out the value. All right. Now, infinite loops, just to quickly touch on these, they're loops where the condition is always evaluated to true. Usually it's unintended or it's an error. You don't want an infinite loop. Sometimes programmers use infinite loops, and then you include a break statement in the body to actually control it, okay? Other times, infinite loops is what we actually want, and you can have an event loop in an event-driven program or an operating system or something like that. But very rarely will you probably come across a case where you need an infinite loop. Here's an example of an infinite loop. So while true, so we're just literally using the value of a Boolean true, then do you want the loop to run again? Yes. And then if, again, if their answer is uppercase n or lowercase n, then we just use the break keyword, okay? Now, nested loops is the one last thing I want to talk about today before I introduce the assignment. Nested loops is basically a loop within another loop. So just like nested ifs, we can have nested loops. Now they can be a little bit more confusing, and they can go very many, very, very they go many, many levels deep, sorry, as the program needs. So you can have one loop inside of another loop, or you can have another loop inside of another loop inside of another loop. It just can get a little bit confusing. They're very useful when you have multidimensional data structures. So if you have a multi-dimensional vector or something and you want to loop through and print everything from the second dimension at the same time as the first dimension, you can use two loops to do that. And we usually refer to, when you have multiple loops, we refer to one as the outer loop and one as the inner loop when it's nested, okay? So taking a look at an example here, we have the outer loop here, which is a for loop, and we have our outer val, which is set to 1, and then we're checking as long as outer val is less than or equal to 2, we're going to iterate outer val by 1. Then our inner loop, we have our inner val. So this is instead of using the variable I, we're going to set it as long as it's less than or equal to 3, and then we're going to print inner val by 1. Then basically inside of all of that, we have our cout, which will print to the console the value of the outer val and the inner val. And it would look something like this. Your first loop would run once, and then we can see it's going to run as long as it's less than or equal to 2. And then we can see our inner loop is going to run while it's less than or equal to 3. So your first loop, while it's still running once, your loop on the inside is going to run 1, 2, 3. And then by the time it's completed its third, the outer loop is now going to be ready to complete it or to begin its second iteration. So we can see the values here printed. We have 1, 1, 1, and that's all the values from the first loop. So 1, and then 1 from the inner value. 1 still, because it's still on its first loop, but now the inner loop is on its second loop. Then 1 still on the outer loop, but then 3 on the inner loop because it's going to go until it's equal to 3. Now the outer loop is ready to begin its second iteration. So it's now 2, and then we're re-looping at the beginning of the second loop. Our inner loop also restarts, and then we do 2, 1, 2, 2, 2, 3. Does that make sense to everyone? Hopefully that makes sense. All right. So it's very useful if you wanted to print something like a multiplication table. So in this example, and I'll show you in CodeLight how this works, but we have our outer loop, which is going to be a number from 1 to 10, and then another inner loop inside of that, which is also numbers of 1 to 10. And then we're going to see out to our console the number from our outer loop times the number from our inner loop. So you're going to get 1 times 1, 1 times 2, 1 times 3, 1 times 4, 1 times 5, all the way up to 10. Then you're going to get 2 times 1, 2 times 2, 2 times 3, 2 times 4. And it's going to display a 10 times 10 multiplication table all the way up to 5 times 5 times 5 times 6, 5 times 7, all the way up to 10 times 1, 10 times 2, 10 times 3, 10 times 10. Okay? And I'll show you guys an example of that in a second. It's also useful for 2D arrays. So here we can set all the elements to 1,000. So inside of our 2D array, we have our outer loop and our inner loop, and then we are using it to set elements inside of each loop. And then we can also use it to print elements from a 2D array here. So we have our outer and inner loop, and then we are printing to the console at each row and each column in that loop. A couple more slides here, guys. Just bear with me. You can do it with the 2D vector as well. So if you have a vector of vectors of type int, and we've given it 3 rows, three columns, 1, 2, 3, 10, 20, 30, 40, 100, 200, 300, 400, and 500. And then we just have a simple for loop using our auto keyword. It's going to loop through for each element in that vector. And then we have another inner loop that's going to loop for each element in that vector and print out the value of that. So it's going to do 1, 2, 3, 10, 20, 30, 40, 100, 200, 300, 400, 500. All right, so just a couple examples of nested loops, and then we'll be into talking about the assignment. So just one example here, really, for my nested loops that I want to show you. So this is the multiplication table. So I've got my outer loop, which is going to be an int called num1, setting it to 1, and while it's less than or equal to 10, num1 plus plus. Now my inner loop is going to be called num2. I'm also setting it to 1, and I'm also saying while it's less than or equal to 10, I'm going to do plus plus num2. All right. Now we're going to print out num1 times num2. So we're just printing out a string is equal to, and then here we're actually performing the mathematical operation. and then we're going to exit the inner loop, and then we're going to do a bunch of dashes once we finish our first iteration of the outer loop. Okay, and then it will do that whole process 10 times. So if I can do a very, very rough drawing of it, imagine like a clock or something like that, okay? And you have your outer loop, which is like this, okay? And it's a perfect circle. And it's going to run through and it's going to be printing 1 the entire time, okay? Because it's on its first iteration of the loop. In here, we have our inner loop, and it's going to be running, and it's going to be printing 1, 2, 3, 4, 5, because it's actually running through 1 time, and then it's going to run it through 2 times, and then it's going to run through 3 times, and it's going to do that 10 times. And once it prints 10, then we now begin our second loop on the outside. And it's going to do all 10 again on the inside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then now we begin our third loop, right? And it's a little messy, but it might help you understand, just like the hour hand on a clock goes from 2 to 3, but the minute hand goes all the way around in an hour through 60 minutes, right? The minute hand loops faster than the hour hand because the hour hand takes 12 hours to get all the way around the clock, right? Okay, so let's run this program. Let's see what it looks like. And there we go. A lot of printing to the console, but we can see exactly what we expected. So this is on its first loop iteration, and our inner loop looped 1, 2, 3, 4, 5, 6, 7, 8, 9 times, 10 times, and then it actually just did the mathematical operations. So 1 times 10 is 10. Now our outer loop loops its second time, and the inner loop re-loops. So it's the exact same repetition, 1 to 10. But now the math is going to be different because it's 2 times 1 instead of 1 times 1. It's going to be 2 times 1, which is 2. And it's going to do this until the outer loop loops to 10 times. And then we're going to get 10 times all of these numbers, and finally get 10 times 10 is 100. Cool. Awesome. I hope that was helpful for you guys. That is loops and nested loops, do while loops, while loops. What was the other one that we covered? We covered the for loop and the range-based for loop. I'm going to end the recording here, and then we will begin a new recording when I cover the major assignment 1, okay?